So let's talk about the analysis of variance, ANOVA. In this lesson, we'll talk about the fundamentals of ANOVA. So let's get started. ABC manufactures a variety of nylon products, including safety belts for automobiles. To keep drivers safe, the nylon in these belts must be able to endure a great deal of stress. ABC's quality engineer ensure that only strongest nylon is used in the belts. They measure the tensile strength to rate nylon's ability to withstand stress. ABC purchases nylon fiber from 5 different suppliers. Suppose a quality engineer at the company wants to compare the strength of the fiber from 5 suppliers to determine whether the strengths differ, and if so, to determine which of the suppliers produce the strongest fiber. In Chapter 3, we use the two-sample t-test to compare two population means, but how can we compare the means of more than two populations? One-way ANOVA, or analysis of variance, is an extension of the two-sample t-test. When we are comparing the means of two populations, we can use either the two-sample t-test or one-way ANOVA. However, we can use one-way ANOVA to compare the means of 3 or more populations. Before we can use ANOVA to answer these questions, there are 3 key concepts we need to understand: factors, levels, and responses. In the ABC study, we have focused on the supplier as a possible cause for differences in tensile strength. In doing so, we have defined the explanatory variable, which we call the factor. Alternatively, we might have selected safety belt design or factory of origin as our factor for this study. A factor is categorical, meaning the data classify people, objects, or events. In one-way ANOVA, there's only one factor. Each of the 5 suppliers represents a level or a group within the factor. Therefore, the supplier factor has 5 levels. After defining our factor and levels, we are ready to examine the values being measured in the study. In ABC's case, the tensile strength, we call this variable the response. The response is continuous, meaning the data are measured quantities for which fractional values make sense. We can use ANOVA in many different situations. For example, a company is considering purchasing one of 3 expense reporting software packages: Basic, Premium, and Business. They have decided they will purchase the one that is quickest to use. A number of employees are randomly selected to test the packages and report the amount of time it takes to fill out an expense report. So what is factors, level, and responses? So we can see here the software. The software is the factor. Software is the factors because it is our explanatory variable. The 3 software packages are the levels that comprise the factor. The amount of time it takes to fill out an expense report is a response because it is a variable being measured in the study. So let's return to the quality engineer at ABC. She collects 7 spoons randomly from each supplier. Then she takes a measurement of each fiber sample in random order to measure the tensile strength. She applies an increasing force to the fiber until it breaks. She now records the 7 responses for each level of the factor. In the later lessons, we'll learn how to apply ANOVA to compare the means of the factor levels to determine whether the levels differ. So let's review. In these examples, we can use ANOVA to determine whether the mean responses for 2 or more groups differ. There are 3 key terms in the organization of ANOVA data. The factor is categorical variable, that is explanatory variable in our study. The levels are the groups or categories that comprise the factor. The response variable is the value being measured in the study. As mentioned, the engineer selects 7 spools randomly from each of 5 nylon suppliers. In random order, she takes a fiber strength measurement from each spool. Now, how can she interpret this data? Thank you for your listening. In the next lesson, we'll talk about the graphs and summary statistics.